In this section of material, we're going to be talking about linear inequalities in one variable. And if you'll remember from us talking before about equalities or equations, we said that a linear equation came in the form of ax plus b equals c. And that was what our definition was. We'll look at the definition of a linear inequality. Very, very much the same. The only thing that is different is our symbol, because here we had equality and here we do not. This is an inequality, or not equal. But also notice that they've listed it out as almost 4 different things. We don't have to think about it that confusing. Just think about what you know already. You know that the less than symbol looks like that, and the less than or equal to is that same symbol with a line underneath it to indicate that we have less than or equal to, both of those situations. The greater than symbol is the one that looks like this, pointed to the right. Greater than or equal to then would be the greater than sign with also an equal bar. Don't forget these. These are extremely important. Another thing that's very important to remember is that it always points to the smaller number. So, for instance, if you were comparing numbers, let's say we were comparing 5 and a -3. Well, because the -3 is smaller, the symbol would point to that number. So this says 5 is greater than -3. Now let's just graph some inequalities, things that should be reviewed, you should have done before. Whenever we see x is greater than 5, that literally means all of the numbers that are larger than 5. So if we look at that on a number line, let's say here is 0, 1, 2, 3, 4, 5 would be right there. And that would be everything from 5 on to the right. The x's less than or equal to 2, if we were to graph those out, I know I'm not finished with the first one, we're going to go back to it. Here is 0, 2 would be here. The things that are less than or equal to 2 would be from 2 back to the left, and for on and on and on. Now, you may have used open circles or closed circles in the past in order to graph your inequalities. That now has to be changed to parentheses and brackets. We use parentheses if the endpoint is not included. We use brackets if the endpoint is included. So like for our first problem here, we had x was greater than 5. So that endpoint, or that 5, it's not included as part of that solution, because 5 is greater than 5 is not true. Since the 5 is not included, we have to put a parenthesis around there. For that next one, though, x is less than or equal to 2, we have equal to. So that means that the endpoint will be included. Like, for instance, if I said, is 2 less than or equal to 2? Yes, it is. That's a true statement. So this endpoint is part of the solution to this problem. In that case, we use a bracket. Now, we also have interval notation that we could write this in, and we're going to talk more about it here in a little while also. But interval notation is so nice to be able to write because you simply look at the endpoints. For instance, this first graph that we did started at 5, and it goes all the way to the right, all the way over to infinity, forever and ever and ever. Now, we need to write this in interval form, so that means brackets or parentheses on the outsides. And we already have that information from our graph. Our 5 was not included, so that gets a parenthesis. Infinity always gets a parenthesis because we don't know where it's at. In the next problem here, we always read left to right. This starts way out here in the left at negative infinity, and it goes all the way up to 2. Infinity always gets a parenthesis because we don't know where it is. But 2 had a bracket in our number line, so it gets a bracket again in interval notation.